Okay, so what is it that you feel you would need and or want to go over? Okay, chemical reactions. Yes.
So on this test, we're not allowed to use our periodic table?
You can use your periodic table.
I know.
Okay, tools you can use. Periodic table, slide rule.
Oh, good stuff.
Okay. So, what are some examples of classifying these chemical reactions?
Periodic table?
No.
The name? The number?
No, no.
The atomic number?
When you name would be right.
No. The letters.
Well, yeah. What are the letters? Once you get one, the rest are going to fall into place.
Atomic mass.
No, not atomic mass.
Atomic number.
No, not atomic number. No. You wanted to go over chemical reactions. I said, what are our types of reactions?
Combustion.
There's one.
Synthesis.
Synthesis.
Shoot, I forgot all of these.
Single reaction. Oh, single replacement. Double replacement.
Oops. Double replacement. Okay, so that is where you decide what is it that you feel you need to go over.
Combustion.
Then. Combustion. Okay.
Yeah, can we do like examples?
Well, we can, but we'll let you pick what order you want to be going in.
Yeah, we'll go with combustion first.
Okay? Checking your grade. Oh, we're checking our grade. Okay. All right. Okay. So give me an example of a hydrocarbon.
Elemental thing.
No. No.
Could you restate the question, please?
Give me an example of a hydrocarbon.
Water.
Okay, now, what's the ratio of our hydrocarbon? How many carbons?
One carbon.
Okay, how many hydrogens?
One. Two.
We can do two if you do you really want to do two. Okay? So this is natural gas or what compound?
H2O. C.
No, what compound is this?
Let me grab my other notebooks.
That's
Methane.
It's methane, okay, or natural gas. If natural gas will combust, it's combining with what? Anything significant about that oxygen? It's diatomic, okay? And probably for the 22nd time, maybe, it bugs me. Well, it doesn't bug me. I just think it's silly to say. For the millionth time, no, that's rather unlikely. So maybe for about the 22nd time, what elements fall under this category of being diatomic?
Any oxygen?
Well, we've accounted for that.
I mean, no, any gas.
Any gas except noble gases. Okay? So what's another example of a gas that's not a noble gas but still diatomic?
Argon?
Hydrogen. That's a noble gas.
No.
Nitrogen. Those are the only other two gases. And then, well, with the exception of chlorine and fluorine because those are halogens. Okay. So once these combine, what are your byproducts every time in a combustion reaction?
H2O and CO2.
I'm just going by what we heard first. Carbon dioxide. Okay. What is something very specific that you can do to help yourself out should you see this hydrocarbon written that way?
Have to.
Okay.
I think we should start
Am I wrong or right?
things under.
Well, let's see how it works out. You said double this.
No, I think you only double it when
I also think
We're going by what we heard first, but is that logic sound?
Yeah. So,
Yes. Okay.
well, can we write our little deals out, like the line? You know?
The numbers of them?
Yeah. Yeah.
What's significant about this is it's, yes.
Would carbon have a plus 4 as a thing?
Yeah, it would. Right. Okay. So kind of a inside joke you could say is this is not the only time that you see this because we've seen this before too. But you just never applied it. You don't write this down. Okay? It's because of this. It's always a learning opportunity.
What?
Do you have any like practice worksheets that we can use? Like study worksheets that we can work on?
Yeah.
That's why we're doing it now.
Like, do you have like extra sheets from like that we can like re-practice them on?
Yeah.
Not really like.
Well, you can always just get out your papers that you've collected over the semester and do that in class. That's what I perceive that you mean. Okay, well, let's not go into that. I'm afraid it's just going to confuse you. I just thought it might be a way to, let's say, jokingly go into this. It was a joke, but we'll keep going. Okay, so carbons left,
1,
carbons right,
1,
hydrogens left,
4,
hydrogens right,
2.
oxygens left,
2,
oxygens right.
1, 3.
Okay?
I'm blind, am I right here?
So now, what is it that we can do? You've already answered this question. Yes.
Gotta make
Put 2 in front of.
times the oxygen on the right one of them.
Yeah, times put 2 in front of the H2.
Oh, put a 2 in front of the H.
Okay. So what does that change on this side?
Gives us 2 oxygens and 4 hydrogens.
Okay?
Gives us, yeah, gives us 4 oxygens.
4 oxygens and 2 hydrogens.
Oh,
2 hydrogens?
4
Oh
hydrogens.
my god.
Okay.
And then you put a 2 in front of the oxygen on the left side.
Put a 2 here.
Yep. So it's 1, 2, 2 to 1.
Does that look balanced?
Yeah.
Yes, it does. Okay?
These were always my favorite.
All right. Combustion reaction.
Can we do a more confusing one, like the C2H8 or something?
Sure. The numbers just happen to get a little bigger, but nonetheless, it's a combustion reaction. Should we be mean?
Yes.
Okay.
Do something that would be on the test.
No.
Well, like an example. Not like, yeah.
Well, that's what we're doing. I'm not doing examples of what's on exact problems that are on the test. That's what I perceive when you say that.
Is you being mean to us going to be on the test?
he's not going to call us
No.
names through the paper.
Yeah.
Okay.
Some of you individuals.
Just do a difficult one and then we can figure it out.
Brenla?
As some of you cannot read, I will not be informing you.
Okay, we're starting to have problems in here. Okay? The numbers just get to be a little big. How is this a combustion reaction? Yes. So just like the prior example, but what can you tell me the biggest difference besides numbers? I get that they're inflated. We have already established that. But what is the biggest way and best way you can help yourself out with
Put a 2
this?
in front of the H, the C.
No, let's see.
Why? That's correct, but why would you do that?
Because it makes it easier.
Well, yeah, it's going to make it easier.
Makes life
But
easier.
recognizing that, do we need to write these out again?
Yeah.
Okay, carbons left,
10,
carbons right,
2, 1,
3.
hydrogens left,
Probably 22.
hydrogens right,
Yeah.
oxygens left,
1.
Oxygen's right. Okay. So, other than these numbers are bigger, we've already established that. But what is it that you can do to help yourself out the best? And you would put a 2 there, but that doesn't explain why you would do that.
That's how you taught
easier
us.
so that you're not putting a 5.
Okay, so again, besides numbers, what do we see is the difference between these?
One is odd,
One is odd, this one is, that's right. Okay, so if we're spending time on that, there must be a significance. If that is even, why is that significant?
Makes it easier. You can't.
Okay, so do you want to see what will happen if you don't, or just show you the right way to do it? Okay, so we recognize this is even. So we're going to put a 2 here. Okay, 2 times 10. Okay, then go back and do your hydrogens. 2 times 22. Okay, so let's do our carbons on the right side now. If you've got 20 on the left, how do you get 20 on the right? Okay, so don't get too wrapped up about your oxygens yet. Okay, let's go ahead and do our hydrogens. Hydrogens left.
44.
Okay, so we only have 2. How are we going to get this up to 44? Okay, and this is why just worry about your hydrogens next. Okay, so 22 times 2. Okay, and then 22 times 1. Plus sign in between these. 20 times 2. 40 plus 22. So therefore, 62 divided by 2 is what? Okay, and then we said this was 62. Oops, I did that wrong. I got to put the 31 up there. Not, it would be down here, but that means we've got 62. Okay, what's 22 times 1?
22.
What is 20 times 2?
40.
What is 40 plus 22? Okay?
Right? Starting to come back a little bit.
Well, you know, when it comes to yes. When it comes to trying to remember this, is this a lot of content?
Yeah.
What happens if you do this?
It just stays in your head.
Just plug your ears so it doesn't fall out then. That's all you got to do.
Thank you.
Yeah. Just don't do that when you go home and you say, I can't listen, I can't listen. Okay, so what's your question?
There's the slide rule, but there's the other way you could do it. That was where that confused me.
Oh, the noble gases?
Yeah, using the
So
noble
what I did is I did the Bohr model for that, and then it just gave me the answers for the other thing. So when I
There's nothing wrong with that.
and then I forgot what the starting point would be.
Okay?
For that.
So, that was a question that was asked. Do you want to do going back, or you want to do more reactions? Do we want to address this question? I don't care. This is your time.
I feel like we should just stay on one topic.
Well,
for
that's
each day.
that's what we're asking.
I think we should stay. And then tomorrow we can stay.
Are you okay with that?
Hayden, do you think we can just do it tomorrow?
Are you o-
Just stay on.
If I don't forget about tomorrow, I'm sure.
We won't forget.
Write it down.
Yeah, write it down.
Just say yes.
Sure, yeah.
Okay.
Didn't say
And can
yes.
we move to
Fine. You like that?
So, we've done this one.
I'm trying to figure out what he means.
Okay? It's just as important. If you know what a synthesis reaction is, okay, what the definition is, you can help yourself out immensely or a great amount.
It's the opposite of decomposing.
Right. So just give me a metal. Iron? Okay. Which type of iron?
3.
Okay. Why do you suppose that needs to be pointed out?
There's not an iron 3. Is there?
There's iron 2 and there's iron 3. That's why. Okay, so what are we combining with this iron? It has to be a negative ion. Or do you, lithium? Can't do two metals. We need a negative ion. Okay, so how are we going to write this? Cl what? Why do we need a 2 here? For the 23rd time now. Because it's diatomic. Now, the last question that we had asked that's important, is this iron 2 or is this iron 3? 2. Okay, and when you say iron 2, that's what makes the difference when... Shocking, huh? You know, I could probably shoot that right through there. That's a pretty good target. Okay? How are we going to balance that out? This is where it's important when you said iron 2, because you don't know what charge the iron has. But you had said it's iron 2.
So iron plus 2.
Okay? So that means when you say iron 2, that's plus 2. What's the charge of chlorine?
Minus 1.
Minus 1. What's the least common multiple?
2.
So which one of these needs a 2? And this is why. The answer you get when you divide them out, correct? For maybe the 13th time. The answer that you get from your least common multiple, which is 2, divided in here, tells you what to put below. And what is significant about this equation?
They combine it.
It's synthesis. We don't need to go any further.
Yeah,
It's already balanced. You have 2 chlorides on the right. You've got 2 chlorines over here. Now, why might we say chlorines and chloride over there?
Because it's by itself over there.
Because it's by itself. This is a neutral. If you want to say molecule over here, it has ionized to where we have chloride.
Does it react or do anything
It's highly reactive. It's actually poisonous
if it's by itself or when it's together?
when it's by itself.
But if it's with iron.
It's stabilized quite a bit. There has to be something from the activity series that would react with that to boot the iron out. That would probably be something like a lightweight gas, like perhaps hydrogen or maybe lithium and sodium. All right. So there is your synthesis reaction. Okay?
Same thing with backwards. Yeah, it just starts off like.
So we need, I don't know if that one will show up. Okay, we need, give me a compound, in other words, something like this. We want a transition metal. Okay, not a transition metal, but it'll work. What compound do we, not a polyatomic ion, but something that's negatively charged?
Iodine.
Okay? So, how do we finish writing that compound out?
Yeah,
Aluminum has a -3, right?
No, thank you.
Dallin wants a cookie.
Okay? Those don't add up to 0.
Nope. So the greatest common denominator factor is 3. So then iodine has 3.
Okay? Least common multiple is 3. So, what is 3 divided by 1?
3.
What does that mean we got to put here?
3.
Okay? What is 3 divided by 3?
1.
Do we need to put anything here?
No.
Okay? So are we adding anything here, or is the arrow next?
The arrow.
Okay? All right.
And then AL plus I. And that's
Aluminum is
It's a metal.
iodine is?
What
Yeah,
column is it in? It's a halogen.
Yes.
So we just followed this and put the 2 over here. Let's do that.
2.
why is that 3?
No, you put it.
I mean, that's what we did up here. Shouldn't we do that here? No, don't do that. It's diatomic, which means you need a 2 there. Okay?
Alright. Now,
The least common multiple between 2 and 3 is what? 6. Okay? So 1, 1, 3, 2. These are odd. These are even. So let's get this up to an even number. Take it times what?
You think that too?
2 times 1.
2.
2 times 3.
6.
Okay? We've got 2 aluminums on the left and 1 aluminum on the right.
You take it by 2.
Take aluminum times 2 and then take iodine times 3.
That's not what I meant to do. Okay.
Alright, got it. Now, single replacement.
Okay. Now what? Yes. Yes.
Single replacement reaction.
Single replacement. Okay.
Which one is what in? It's in the second. It's in the third row.
Fellas, volume.
Third row.
Column. Columns are up and down.
Okay. Now,
Doing column.
I know you're helping, but it's getting out of hand. All right.
Yeah, Hayden, I think you should probably listen to the teacher.
All right.
Students.
So,
What I'm doing.
Or just pay
He ain't on
attention.
my
Yeah,
level
just
yet.
pay attention.
Obviously not.
What do you mean? Obviously not.
okay.
By the way, it sounds over there.
Doesn't sound like you.
Okay. Do you want an acid or a compound?
Compound.
Okay. So, a transition metal.
Oh. Zinc.
I don't like zinc, and aluminum's not.
Silver.
I don't want silver. We've done that before too.
Gold.
Not gold.
Nickel.
Okay. What about this nickel?
It's plus
4.
Okay. A polyatomic ion. Sulfate, carbonate, phosphate, hydroxide, phosphate. Nickel 3 phosphate. What are we going to add to this nickel 3 phosphate? I need just, how about lithium?
Alright.
Okay.
three. Never mind.
Okay. Notice we're kind of doing this backwards just a little bit. So with that, what is the symbol for nickel? What is the symbol for the phosphate ion, or symbols?
PO.
Okay. The charge of phosphate, negative.
-2.
Okay. What's the charge of this nickel?
Plus 3.
Plus 3.
Why do we not have to guess what the charge of nickel is?
Because it says it.
Okay. Human nature. Probably the 11th time now. You laugh, but we might observe this. Someone might do that. Why?
Because it's not.
Because
That's probably the biggest reason right
they
there.
think that the 3 is indicating that something
Okay?
Yep, yep, yep.
So then, does this add up to 0?
Yeah.
Okay? Then, what is the symbol for lithium?
L,
Okay? So then, since this is a single replacement, this is going to replace what, but on that side? The nickel. Does this 4 go over there for sure?
Yes.
That's right. Why?
Because it's part of the equation.
It's part of this formula. Okay, so you want to do nickel first or lithium? Okay. Lithium is going to replace the nickel. So then what's left over from this compound? Okay. And then since this booted out the nickel on that side, that means this is remaining, correct? Are we done on the right side? No, we are not. So what is the charge of phosphate?
-3.
Okay. What is the charge of lithium?
-1.
What's the charge of lithium?
I'm at +1.
Okay. Does that add up to 0?
No, you have to put it over 3. Under 3.
Okay. Under 3?
Over 3. Over 3. Well, like you put 3 over top.
Oh, okay. What's 3 divided by 3?
1.
Do we have 1 phosphate?
Yeah.
Yes, we do. What's 3 divided by 1?
3.
So now when you do that division, why is that important?
You have to have 3 lithiums.
Okay?
And you have to put it, yeah.
Right. Can we proceed to balance now?
Yeah.
Yes, we can. Okay? So, nickel. What else do we see?
Lithium.
Okay? Now, you can do that. And I would almost pretty much guarantee you that that makes things a lot easier when you keep them together. But you can do phosphorus and oxygen. Okay? Okay, so nickels left,
1.
nickels right.
1.
5 cents, right? Okay? Yeah, it's 5 cents. Mm-hmm. Lithium's left. Lithium's right.
3.
Phosphates left. Phosphates right.
1.
Okay, there's only one place to start with this.
Put a 3 in front of lithium.
On the left side.
Okay?
Shut up, down. Sorry.
No, no. All right. Is there anything else that we need to change on that?
No.
No. It's balanced now.
1, 3, 1, 1.
1, 3, 1, 1.
Now, double.
Okay. I think we'll do a double replacement reaction, and then there's something else that we need to discuss. It was brought to my attention, and I don't know. We'll have time. I think we will, and we'll address that in just a moment. Okay, so now we've done our single replacement. Okay, now make this compound as simple or as complex as you want. So the best way to do that is with a, let's say, a transition metal. How about chromium? Okay, chromium. What type of chromium? Okay. Okay, a chromium is 24, I believe. Okay, chromium, we want a monoatomic negative ion. And if that's confusing, remember, that's a polyatomic ion. That's a polyatomic ion. This is a polyatomic ion. So a monoatomic negative ion might be what?
Chlorine.
Okay, oxygen even. You could even use bromine. All of those are monoatomic negative ions. So, what do we want for a monoatomic negative ion?
Bromine.
Even though we're not going to say bromine, I almost did it myself. It's been ionized is bromide. So, no, that's fine. That's how we learn. Okay? What are we going to add to this? You can, let's do a, let's say an alkaline earth metal. So what column is that?
Second.
Okay? So, magnesium. Okay? Now, we want a polyatomic ion. That's negatively charged.
Fluorine.
Nope, that's monoatomic. Okay? Hydroxide. Okay? So I think, I know we requested to do each and every one of these, and we're doing that, but to me, this is the best way that you learn what a double replacement reaction is. Okay, symbol for chromium. Okay? The bromide ion. Must be, is that because it's cold?
Yeah.
Brr. Huh? Brr.
Because it's all
Okay.
the way in the seventh column.
All right.
Oh, he said burr, like it's cold.
All right. So, magnesium is what?
MG.
Okay? And then the hydroxide ion.
O8.
Oh, yeah,
OH?
H.
Yeah.
O.
oh, in parentheses?
OH?
No, you don't.
Just H?
Oh, it's two.
OH?
No.
Yes, it's
OH?
It's OH.
H.
Yeah.
It's just H.
Oh, okay. All right. So then, are we done with this compound?
Knows
No.
Chromium has a +2 charge, and
you need two.
bromide has a -1. So you have to add a 2 to bromide.
Yes.
Okay? That's a 2, by the way.
But hydroxide
Now,
is
does this make sense on why that 2 is there?
Yes.
It's there to balance out the compound. Okay, hydroxides, negative what?
1,
Okay, magnesium,
2.
that does not add up to 0.
How about
Put
let's say
OH in parentheses and put a 2.
Okay, because one hydroxide ion is negative 1, but we needed 2 of them, so that's why the 2 is on the outside of the parentheses. So where does this compound split?
The
bromine and magnesium and chromium and hydroxide.
Between the positive and negative ions. Okay? So what does chromium bond to from this compound but on this side? Okay, chromium hydroxide. Okay? Does this 2 go over there for sure?
Yes. No. No.
No, that was used to balance out the compound.
But it will.
Okay? But it's going to, because charges do not change. Least common multiple between 1 and 2.
2.
Okay? And then what's left over?
Magnesium.
Magnesium bonds to what, but on that side?
Bromide.
Okay?
And the 2 will come over only because the charge.
Because the charges do not change, just like what we saw here.
So this is.
Do we have to do anything else to that reaction?
Yeah.
Get a balance. Oh, no, you don't.
No.
No, nothing changed. Because this was a +2 charge with a negative ion. This bonded as a +2 charge with a -1 ion. So that didn't change. This is a +2 ion that bonded with a -1 ion over on that side as well. So sometimes when you write these out, they're already balanced.
Just got lucky.
Right. Okay. Questions over this? Okay. So this is an entire science of what we call general or inorganic chemistry. Those papers that were handed back to you is a branch of chemistry called what? Organic. Okay? So someone had brought this to my attention, and if we have time, we will do it, and that is doing an organic activity. Okay, so what that means is I'm just writing this down so it makes sense. Okay, this is a senior level application that they're responsible for doing. But what happens, okay, is one of the aspects of something that you are familiar with okay? So sometimes when we see these, maybe it's better to, let's see here, and I think, so what you see is this is a structural formula, this is a molecular formula, but we can write a structural formula for this too, and that's probably a better way of doing it, okay? What classification of compounds is this? What classification of compounds is this? Okay, so we go through a process, it's called esterification, okay? With a little help of a catalyst and some heat, okay? What this does, the heat in the catalyst breaks these molecules apart, okay? And then what happens is this gets stripped off of there, and then so does this. What you see inside the boxes is vital to understand what molecule that is. What might it look like?
Hydroxide.
That's a hydroxide. And then what do we have here? What might that be?
I'm kidding.
That's not false.
Oh.
You're going to say, I knew that.
Alcohol.
Hydroxide.
How many hydrogens do we have?
H2O.
That is vital to know, okay? Because what happens is when these reassemble then on this side, okay? Notice that this oxygen's all by itself, right?
Yeah.
Okay? So then what's left over from this compound?
A double bond between.
So then this carbon, okay, is this one right here, okay? And it still has this on it. This is what we call a complex ester. And esters give off fragrances. So what this does is in this chemical reaction creates a specific fragrance, which is organic chemistry. So Thursday, I'm thinking Friday would probably be better because chances are, what is it with, we can catch up to you next time.